also proved lethal. Here's a picture of the oscillator. They were also proved lethal to cancer by Royal R. Wright. Dr. Abrams made thousands of his instruments, which were all suppressed and destroyed by the Food and Drug Administration to protect the drug monopoly. Just as Wright's instruments were destroyed by the AMA and by the Food and Drug Administration, by the state of California, and of the federal government of the United States of America, in total corruption and disregard for the law. Now, the spikes that you see on their frequencies are the lethal part that kill and devitalize the virus. They are the resonant peaks of the frequencies which increase the voltage to a very high potential, which the cells of the virus walls cannot tolerate, and they break up into many pieces and are destroyed without harm to the human cell, which has cell walls about 100,000 times stronger than the walls of the virus. So it can readily withstand the low voltages applied, which are in the area of 1 to 5 volts in the human body. And the ray tube voltages, which go up to 7,000 and 8,000 volts, the potential energy is directed to ground, and the audio frequencies are transmitted off from the ray tube, which is nothing more than an antenna to release the audio frequencies which do the work of devitalizing the virus.
Now, in the beginning, you saw the Abrams machines, and this is a solid state version of the tick-tock or the deadbeat oscillator that's shown to you on the front there. This machine consists of a Tesla coil right here and a solid state timer that drives a Darlington setup to trigger the Tesla coil, so that we get these exact same wave shapes and lethal frequencies on the wave shapes. And this control here is a resistance to these electrodes. These are the electrodes that stick on you right here, and you can control the amount of current through the electrodes by using this stepped resistor bridge. But basically that's all there is to the machine. There's the Tesla coil fires through the same type of circuitry as your nervous system, a condenser and a spark gap that's set below 1/16 of an inch, so that we sort of get all the frequencies fired at one time, and then a neon tube that lets it go back to this collector before we take it out. So it's like an amplified version of the deadbeat oscillator. So what I want to do now is we're going to go up to the tube and start this thing so that you can see what it looks like on the scope when it's running. Now right now there's nothing triggering there until we start it. So we're going to start the power supply, and you can see how this works. Now these are the just about the same wave shapes. You can see as we spread it out here on the scope, we have quite a few more resonant peaks. So we have a bunch of different frequencies that we're gaining here. And we can set the spark gap to eliminate or add as many of these frequencies as we want by the distance in the gap. But basically this is what it looks like. It's set at a certain frequency to do the pulsing, which is no more or no less than what the Abrams deadbeat oscillator was. You can see it sort of rings down here, and if you get the original nerve tracings of Abrams out, you can see it's very similar to the deadbeat oscillator. And if we spread this out, these are the frequencies that we have in there, all combined in just a little spike. So let's see here, let's brighten this up just a little bit. See? That's about as bright as it's going to get. But all these frequencies are combined, and all these frequencies in this wave here are contained in a spike and this is what it looks like going through there until we spread it out. So that little spike that's going up and down there has all these frequencies in it when we spread it out. We'll spread it out here, and you can see that all those waveforms and resonant peak frequencies, and it looks like a brush discharge on the top there. That's all contained within that spike. Now down in here too, in the negative half, are also these frequencies down here. So these frequencies are riding through the whole wave. And if one puts the electrodes on and then touches the scope probe to anywhere on his body, these frequencies are all there and they're all riding in the body. So if we took the electrodes here and taped them on and then touched the person's skin, why, this will be right in there. So basically what's happening is the spike is going in there. You can see the spike there with this burst of all these frequencies up in there. It's a very short duration spike, and in fact it's so fast that sometimes the scope cannot pick it up. It just refuses to trigger here until we set it again. But this is what's in that spike. I'm getting the best picture that I can of it because the scope refuses to do any triggering at all. And this all amounts to about a little bit less than about 12 volts. But the spike potential is extremely high. If we go to 0, this spike is at 5 volts per division, so it's 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, almost 60 volts where this spike goes. And I don't know if you can see this in the camera or not, but this spike is up still past the screen, and there's the end of it at about 75 volts. So all this information is in that spike. As we bring it up, you can see that it's all inside there. Now these are a set of frequencies that are about almost 1, 2, about 50 megahertz. So these frequencies are in here at 50 megahertz, and if we slow down, it's all the way down the spectrum until we get to the original. This now is looking at the spike expanded. Those are all the frequencies hidden inside that spike. Every frequency known, just about. And as we go in further, you can see that this spike actually gets narrower and narrower as we get to the pulse until it disappears. But there's the actual spike, and if we go down here, you can see the spike. This is the spike each time. And you can see it there. So it's very narrow. And if we open it up, that's all contained within the spike. And that's the full wave in the picture here. Let's go down to the machine now and see if you can see how the neon fires across the gap. Okay, that part of the circuit that's blinking right here is the neon. And what I'm going to try to do is get this up even more. Let's take the electrodes out so we can get it up here. And get something to hold us basically. So maybe we can get a picture of the spark firing in that gap there. Now if you look real closely, you can every once in a while see a blue arc occur in this gap here. So pause with me a minute, I'll see if I can get the camera up higher, and we'll see if we can get a picture of the many different sparks all at one time in this gap here. We're at an angle to the machine now, and if I go over here, what you're basically looking at is the firing of this spark gap where I'm pointing here is a little blue arc, and what that's doing is creating those resonant peaks on top of the spike. And the resonant peaks, once again, look like this. You can basically see the neon fire and then the spark gap fire. So the spark gap fires first, and each one of these gaps are tuned for resonance to give them that ringing on the top, the resonant peaks of all the frequencies. So what happens is then that gap produces this here. So if we change the gap, then we start to lose these. So it's very critical on the spark gap to get all these frequencies at one time with a spike. And you can see that there's plenty of them in there, and it's not much different. It's just that this scope is a lot better than the one used when Royal R. Rife made the pictures. So we're actually expanding this spike out much further than what they had the capability of in 1936, or in the 20s. So what I want to do now is put this circuit to this whole machine on the blackboard, and I'll just leave that on the film. And I'll leave the camera set up for a while so that anybody that wants to build a thing can do that. But I must remind you at this time, this is just a model to duplicate what the Abrams deadbeat oscillator was. And anybody using this kind of machinery, if they build it, should take precautions not to use it on the highest setting whatsoever if they decide that they want to use it for something. Abrams made it a point in his literature to state that the patient should never feel the current whatsoever, because that would cause the cells to overheat, and it wouldn't do much good. So cells work on microcurrents, and this machine has the capability of being able to be set on microcurrents on the first setting. So you will never feel what's coming out of the electrodes if the machine is properly set. But that's exactly what's coming out of the electrodes, is that high potential with this spike with all these resonant peaks on it. Now what I've done is put the schematic diagram to this machine on the board. This can be stopped and blown up. But basically this coil right here is out of it's a General Motors high energy ignition coil, number C833, and you can get this at most auto parts stores. It's for the high energy system. And this is a neon tube right here, just a regular 115 volt neon set to put in a plug-in panel with a 100 picofarad 1 kV capacitor across it. And then this is the spark gap, which comes out to be something like 1/64 of an inch. And then 100 picofarads is put across that gap to tune in at 1 kilovolt. And off the top of this coil is a 0.0047 mica 200 volt. And then this is fed back into the collector. This power transistor is an amplifying transistor, but a high voltage one, an MJ15024. And the pre-driving transistor that makes up the Darlington is a 2N3440. That can be an RCA part or a Motorola part or a Fairchild part. This pot here, this 100K pot, adjusts the current through the Darlington to make up this spark and the specific wave that we're looking for. This is a 33K resistor off pin 3 of the 555 timer. The timing sequence for this timer is from pin 4 and 8 are tied together. So from pin 4 and 8 down to pin 7 is 200 ohms. Now from pin 7 to pin 6 and 2, which are also tied together, is a 100K and a 47K resistor, because it balances out just right there for the Abrams circuit. So you have to sort of make up this resistance. And then from 6 and 2, once again, these pins to ground is a 2 microfarad capacitor. Now, we've used a diode to isolate the 555 timer in here, which feeds the plus potential of the 555. And that was just a standard diode, 1N4004. And it's filtered by a 1 microfarad capacitor to keep the high frequencies out. Now down here off the collector, you see that this line comes out and goes into a capacitor. Okay, this capacitor can be anywhere from 3 microfarads to 5 microfarads, but it has to be a non-polar capacitor, like a Teflon wrap or a Mylar, any of those type capacitors, and it has to be at least 200 volts. Now this resistor here, down here at the bottom, is very important. I have it on a rotary switch. Now we've used resistors. It depends on how much current you feel safe with. We used a rotary switch to make up a sort of a variable resistor because we don't want a pot that's got carbon. We used metal films because they worked better. And across the metal film is a .0068. That lets the high frequency bypass the resistor so that you get the resonant peaks in the spike. And these are the standard electrodes that I showed you in the beginning of this movie. You can get them from any medical supply house. But basically, that's the circuitry to it. It uses a 12-volt battery, and it does draw 1 ampere of current. So if you decide to use a lead acid, make sure that you get a big enough lead acid so that you don't run out of juice. It's if you intend on using this machine, it's mandatory that you only use it for 15 minutes in a 1-day period. Do not overdo it. And then rest for a day and then use it again for 15 minutes. And that's basically the explanation of this. Once again, on this schematic you can see the 2 waveforms here. And you must get those waveforms when you build this machine, or it's of no benefit. It is absolutely impossible to do away with the Tesla coil. The machine will not function correctly without it. It has no effect on you without that Tesla coil. And that was one of Dr. Abrams' claims in his book too. So all I wanted to do was replicate the Abrams machine, but solid state wise instead of mechanical, since it's much easier for us to build. One other point that I might bring up, the most expensive piece in this whole circuit is that General Motors coil, high energy coil, out of a distributor cap from out of the car. It's a square coil, and if you notice that it's making sounds when you turn this circuit on, it's because the coil is loose in its metal laminations, and all you have to do is just glue it and it'll stop ringing. But basically that's the circuit, and so I'll leave that there for a few more minutes. I'll leave it there for approximately about 2 more minutes, and then we'll go back and put some more of the oscillator waveforms on the camera, so that when you make the machine, if you make the machine, you will get the same wave shape outputs. Okay, now pause with me, and we will look at some more of the waveforms on this oscillator. Okay, we'll turn the power supply on, and these are once again the waveforms that must be coming out of this machine, or it's absolutely useless. And remember, this spike is expanded now because the actual spike is very narrow over here. And you can see it just pulse right up there. And we'll expand it out to get the most frequency so you can see them. And I think the maximum frequencies, according to the scope, are 50 megahertz riding up in there. And some that are well over that. If we expand out more, it's going to get darker. And that looks like 50, almost 50 to 75 megahertz in some of these frequencies. There's 85 megahertz between these two, and it's kind of hard to see. There, but you can see that they're in there. And as we come down to where we can look at the spike, that's exactly what it looks like when it's running. And of course, they didn't have equipment that was quite that good back in the 20s when Rife tested the Abrams machine, so the oscilloscopes were not quite as good as this, or his wave would have looked just like this. If you take the pictures and expand them out on a real tick-tock oscillator, why, this is what you would see. Or a deadbeat oscillator. So once again, we'll take a look at the machine finished and complete. And this is looking at a finished machine. This is your 555 timer. This is your battery input plus and minus terminals. Your electrode terminals come off this resistance switch here that we made up with fixed resistors because we don't want any resistance to ground. That would ruin the effect of the machine. This is the power amplifying transistor that supplies the voltage to the General Motors ignition coil, which is nothing more than a Tesla coil. And the reason that we chose this kind of coil is because it has a separate ground, and we can ground one end to the high voltage. Don't try to substitute this coil. The other coils will not work. And basically, that's the machine. Let's go back up and get the waveforms one more time, and we'll leave the waveforms on there for about 2 minutes so that there will be no mistake in the waveform. Okay, once again, this is the waveform, and it must look like this or the machine is absolutely useless. So we'll let that stay on there for about 2 minutes so that you have a perfect understanding of what the waveform must look like. One other thing that I might add, if a person wants to put a pot in there to adjust the timing response between 60 cycles and 200 cycles max. That's the maximum. So anywhere in this range, the machine works well. Do not attempt to take it up to high frequency or extreme low frequencies. Abrams stressed the point that the machine ran between 60 and 120 cycles. And this is about running at 120, maybe just a little over that right now. But I found, examining this machine underneath the microscope on a test, that it works well between 60 cycle pulses and 120 cycle pulses, and maximum up to 200. I might add one more thing, that the spark gap on this machine is set at a very close gap so that multiple sparks fire at one time. And that's what gives you this resonant peaks in the frequency that you need on top of the spike. That infolds it into the spike. The spark gap must be set extremely close. About, I would say that maybe 10 thousandths clearances in the gap. And the sparking must take place where multiple sparks fly across the gap at one time, or you do not get this type of output. We'll expand this out one more time so you can see all the frequencies occurring inside that spike on the resonant peaks. And there's even frequencies that go up higher than that on the very tips of the spike. But actually these spikes are all modulated with different frequencies as you expand it out. And if you go right down to the spike, it's very hard to trigger because the scope doesn't like to trigger on this. But here's the spike. So that's what it looks like if you couldn't expand it out. It's always changing its frequencies because of the multiple spark gap. We'll bring it back out. It's also going negative down here with multiple frequencies also. So it's almost pretty close to being identical to the waveforms in Abrams' books on the nerve tracings. Spread it out again. You can see these things go way up in frequency and voltage, and that's how they get into the virus. And then the resonance of those spikes, those multiple frequencies, are what shatters the virus like little crystal glasses. So this is a pretty good picture of how they go up. If you expand these out, these are also frequencies, multiple frequencies. So let's get it back in the picture so you can see what's going on there. That's the very tip of the spike. Whole thing in the picture now, sort of spread out so you can see what's occurring inside that spike. Now you should be pretty familiar with the way the wave shape is and the way the machine operates. So good night. And that's what it looks like. This is the important part, is what's up in the peak of the spike, or the resonant peaks. It only happens when you use a spark gap connecting with a neon tube, an Ne2 or something equivalent, as long as it's a gas tube, that the spark can jump the gap through a condenser and then across the neon.
John, this is what, a healing machine or something?
Yeah, this is a Dr. Albert Abrams osciloklastu. From between the 1900s, the 20s, and the 30s, all the way into the 50s. And it's a treatment machine. And this is the machine that you see when you view the Rife films. You know, with Rife, with his cancer machine. And he shows the wave of this machine. He never shows the wave of his cancer machine. He always shows the wave of this machine, which is this spike and a bunch of little squiggles after that. And how this operated in those years, they had mains. They just had copper wires, you know, that were cotton covered like this.
Right.
And you seen them, they were on insulators, you know.
Stretched across the ceiling.
Stretched across the ceiling.
Yeah.
And it was DC power.
Okay.
So that's why this plug, when you look at it real closely, is marked plus and minus.
Yes.
So that you plugged it into the main correctly.
Right.
And these are impulses. And how this thing actually works is the current pulls this in right here. You can see that. Mm-hmm. And it tick-tocks back and forth. So the minute it pulls it in, the reverse coil hits it. And that produces the scalar, the spike. And then then you have different settings here all the way around on these. And there could be 3 people sitting in chairs, and each one getting a treatment from each wire.
So each one of these 3 is the same, essentially?
Yes.
Yeah.
It just a different setting for a different person.
Right.
And it's got a ground. And of course, at Abrams, you sat in the chair, and you had this copper plate underneath your feet. So you were charged and discharged, and charged and discharged. And so the thing about it is how the scalar is generated in this is you've got 2 coils here. Notice the 2 coils are shorted out, so the magnetic field is completely shorted out when this is in the center. But there's another coil that's wound the opposite direction. There's actually 2 coils inside each coil, and it's wound the opposite direction. And so when this contact breaks here, it reverses, and that causes the tick-tock back and forth. And so what it actually does is go.
Yeah.
Well, I have to hold it.
Yeah. Okay.
And it's tick-tock, tick-tock, just like a clock. And this is an original machine. And you can see the old power switch here with the white indicating I'm on, right?
Right.
Something out of the 20s that you'd find on the wall, the cotton cover wire, same thing. The power to the Tesla coils right here, which is located inside the box. And
I think this was serial number 308 or something.
yeah, it's like the 300, one of the earliest machines that was produced. And unfortunately, the story behind this machine is that I located one and got it for $500, and it was packed up, and it worked, and we went to move, and the movers threw it. And so they damaged the whole machine, and it has to be disassembled. And this contactor that's in here is Bakelite, and that has to be all replaced. But I made a solid state machine, which I put on the diagram, which is in this DVD, which is identical to the waveform and the wave shape of this machine, using a HEI coil from a car.
And this was a very popular machine, and and was very, it worked, didn't it?
This worked. This cured a lot of people, and the FDA couldn't have that. And I always had the question about the Rife ray, because what was shown in the film and hooked up was this on his oscilloscope. You know, when you see the oscilloscope, you're looking at the Dr. Albert Abrams osciloklastu. That's what this is.
You mean the wave that's coming?
The waveform that's coming out of me.
It wasn't coming out of a rifle machine. It was coming out.
No, it was coming out of this machine. So.
And that was a film shot by John Crane.
Yes, it was. It actually, that part of it was shot by Rife himself. He was actually able, with his camera, to run the film through dry ice. He was taking such high speed. That's how he got the waveforms on there.
Oh, okay.
On the film. He was cooling off the film as it ran through.
Right.
And so I always had a question in my mind, why is he showing the waveform? Why is he not showing the waveform to his Rife ray?
So if the people were sitting with their feet on a metal plate,
right,
that was the ground, so what, there was a wire attached
to an electrode
attached
to electrode to them. And what this machine did was charge them and discharge them and charge them and discharge them. And right here is a test light. And you push this little thing. The light isn't here because it's a specialized light which got broken. And you push this little test switch right here, and then it made connection through the patient, and this light would light up. And now if you walked up to the patient when this machine was running with a neon bulb, and you were holding that neon bulb, every time the machine would tick-tock, you would see the neon bulb glow, and then go out, and then glow, and then go up. So you know it had to be above 90 volts that the patient was receiving, but feeble. A feeble little tickling frequency, multiple frequencies, because this thing actually, if you took a feather and turned it vertical, right?
Yeah.
All those little spines, you'd see a spike, and then you'd see all these little spikes after that, all the way out.
Yeah, well, that shows up in the video that you made.
Yes.
Yeah.
And that's what you had to reproduce on this. So, and can we get a look at this inside?
Sure.
You know, what was underneath that? See, you can see here that this little wire right here runs to a Tesla coil down here. And this is the actual pendulum right here.
Okay, yeah.
And then these are all potted in. These are wire wound resistors around the contacts. And then that was his frequency setting for each person. And so there's not too much to it. We actually measured it out with this coil here, so we know that it works. That's why you see that there. And so I just thought I would take it apart for everybody, let them know how we patterned our machine. You know, we actually followed the frequencies of this machine.
Right.
And so when we did ours was solid state, more or less. And you had from 0 to 11 positions here.
Right.
So Dr. Albert Abrams could hook the patient to it and say, oh, his best results were at 10, right? Or his best results were here. And what this does is tune the resonance of the output of this circuit from the Tesla coil. By the way, the Tesla coil is not hooked to a thing. There's a telephone coil in there, and then the Tesla coil, but the machine refused to work without it. So none of them worked without it.
So what do you think was going on with the Tesla coil then?
Well, the Tesla coil is a high frequency apparatus.
Yeah.
So it was just making a wave in the room. You know, in other words, like a
sort of preconditioning the.
Yeah, preconditioning for the. But it absolutely hooks to nothing. So whatever magnetic field this thing is generating, the Tesla coil picks that up because you get a waveform on it when you measure it out. And that's in the bottom here. And every machine that Abrams made, if he didn't put the Tesla coil in it, didn't work. So that's a little history on this machine.
So is this your version of that?
Yeah, so what we did was we modeled the Tesla coil. We used the HEI ignition, and that models the Tesla coil down below. And what this actually does, what the osciloklastu actually does is mimic a nerve impulse, but reverse. So it's reverse.
Okay.
So you can hear this. You can actually watch this.
Oh, you can see it. And
Yeah, you can see that's mimicking the nerve pulse, and the treatment electrode is right here, comes out of here. And you just, you touch this.
So do you have an electrode, you have that
Yes, you
attachment wire
have
to an electrode?
Right, you have two electrodes that come out of here. One's ground, and that goes to the plate on the floor.
Okay.
And then this goes to the electrode that attaches to you. And this selects, see?
Just like you did there. Okay.
Just like we did here. This selects the resonant points of it.
So did the electrode have to be anywhere special on the body, like
No, you just
on the
put
head
it,
or on the heart?
No, you just put it where you want it.
Okay.
In other words, if you want to treat this area, you put it here.
Okay.
If you wanted to treat your arm, you put it here.
All right.
So you just place the electrode. But this is a solid state version of it, using the HEI coil.
But you said that the wave that came off it was the same as that wave?
Same as this wave. Identical to it. And it took a long time to mimic it, because you have to mimic exactly what these contactors in here are doing. And so see, you can see this little spark gap in here.
Yes.
See it sparking? That's as if
Between those two things?
Yes.
It's sparking, okay.
Right.
Oh yeah, I can see it.
Right.
I can't.
Yeah. No, you won't see it from there. You need a close-up.
Well, hold on.
All right. So anyway, Pat, we wanted to make a portable machine, because these old Abrams machines are no longer available. And they seem to work, because several people have built these. And
So what are these things for? To get heat away? Or?
yeah, see, this is the transistor here.
Okay.
And this is a timer, so it's timed. And it's set at a certain frequency, and it's got levels that go in and out, and you adjust it for a driver to drive it. And then that's what's pulsing this, doing the tick-tock of this coil. And you can see that the neon light is, every time it represents a nerve pulse, the neon flashes. And if you put a neon at this point over here, if you hold the neon, it will be flashing.
So what we're hearing is not the neon light, it's the
It's
flashes.
the spark, yeah.
Spark, right.
So that's what we built to represent this when I was working with Dr. Strecker and Crane.
Okay.
What
And it worked.
about what years was that?
80, probably 85, 86, right around in there.
Yeah.
And so there you have it.
So people are actually building these and using them, and were they getting better? Or they said
Nobody
they were?
ever reported anything on
Okay,
them.
yeah.
It was like a silence. It's
There wasn't
golden.
an internet back then.
No, there was no internet. It was a fax machine. So you never know. But anyway, Tony, was our model of this.
Okay, great. Well, thanks very much, John.
All right.
Appreciate it. And we've coming up. You also show the video that you shot at the time, and it's also they've got the circuit diagram.
Yes.
So anybody's
Right.
free to experiment with it.
Absolutely.
Yeah. Great. Well, thanks very much. Okay. Shut the cameras off.